All right, so we move on to the second regular talk. We move away from specification, but to a nevertheless incredibly challenging problem, that of layout bugs. Michael is going to present it.
Yeah, welcome to my talk, Fighting Layout Bugs. First slide, who am I? I'm system architect at Optivo. I'm an active WebDriver committer and regular conference speaker. I haven't written a book yet, but I wrote several JUnit tests which read like a book. Okay, maybe not such a good comparison, but here are also some tools I like to use. Big fan of IntelliJ IDEA, Tempest, Mockito, find bugs, just to get a little picture of me. So here's the agenda. I would like to present you 3 techniques to fighting layout bugs. I guess the most interesting technique and the main part of the talk is the last one, detecting typical layout bugs using image processing in JavaScript. But first things first, first technique named continuous HTML validation. The idea is to prevent layout bugs by always delivering valid HTML pages. That idea is everything but new, but I'm curious. Who has integrated HTML validation at a regular basis in its development process? Wow. 4 people. I thought it would be a little bit more. Okay, so how do we do it? The first thing that came to my mind is, maybe you already know, there are some browser extensions which do HTML validation. But those only work in one browser, and they don't validate pages automatically. You always have to click some buttons to trigger the validation. Everyone might argue, well, that's okay. Most programmers only mainly work with one browser and can do this. But there's one killer argument against browser extensions. This is the browser extension can't make the build fail if there's invalid HTML. And that's what we want, don't we? So another idea might be to scan files during the build process, so that you get something like compiler errors. But turns out it isn't a good idea for HTML validation because most of the HTML is in some kind of JSP files, tag files, some kind of templates, or even in Java code. So it's there isn't static HTML files anymore, but there's a lot of presentation logic around it. So, well, I guess it's very hard problem to scan for valid HTML files those templates. So this is not a good idea. So maybe a good idea is to validate HTML during your front-end tests. Yeah, I suppose you have some kind of continuous integration server where you run your test suite. I hope some of you guys already have front-end tests which are run on the continuous integration server. So why not start with a very simple separate test where you visit some well-known pages, start with your home page, and then I guess you know which pages are special on your website and need some attention, and just grab the HTML and send it to a validator. And see if you have valid HTML. I mean, why is it good to have valid HTML, by the way? Well, if you don't have valid HTML, the browser must guess about what you really wanted to have for a DOM tree. And if it guesses wrong, or if you just forget a closing tag, the DOM tree is not what you expect when you write your CSS. And so your CSS selectors don't match anymore, and then you get layout bugs. So, well, another option would be if you have this code which validates HTML, why have a separate front-end test? If you already have a test suite of several front-end tests, then just check every time you get a page if it's valid HTML. And of course, you shouldn't reinvent the wheel. There are already tools which validate HTML, Tidy, or maybe the W3C markup validation service. This is a service you can download and install, and there's also a publicly available server. from the W3C can validate by putting in an URL to your website, or by uploading an HTML file, or by direct input. Here I have some sample HTML with a missing closing tag, and here are some options. And if you press check, you get this red bar, and also here a small red icon, pfeffer icon. And if you scroll down, you get, for each warning or error which is detected, you get a good description why this is wrong. So quite useful, and it's maintained. Yeah? It's always improved, and it comes from W3C. So I guess we should be using this for validation. But I wasn't satisfied with this approach because I wanted to feel faster than that the continuous integration build machine detects that there's invalid HTML. I wanted that it is detected on the developer machine when he is developing HTML or templates or whatever. So I came up with another solution, and with a simple servlet filter. How does it work? First plus point is it works in all browsers, of course, because it happens on the server side. And it validates HTML automatically. Yeah, cool. So, but some other requirements I had, it should not hamper daily work. And it should, developers should have benefit from it, but it should not suffer from it by slower loading times of its pages. And of course, it should also use W3C markup validation service. Yeah, and I wrote such a class which satisfies those 3 points, and here's how it works. I hope you are a little bit familiar with the servlet spec. There's a doFilter method in each servlet filter, and in there, I've wrapped the HTTP response in a THTTP servlet response, and then I say doFilter on the filter chain, so the request is processed, and this response wrapper does 2 things. First, it immediately writes back all the bytes to the browser. So when the HTML goes into the browser as fast as always. And the second thing is, that's why it's called THTTP servlet response, it buffers the response in an internal byte array. And when this method returns, the doFilter method, I have the whole response in the browser, and the browser can do its rendering stuff and so on. But I also have it in my buffer. And if it really is an HTML which was served, it could be something else, CSS, an image, whatever. But if it's HTML, I fetch the HTML from the buffer and send it to the markup validation service. And then I get an answer, red or green, valid or not. And then I haven't closed the response yet. I haven't closed the output stream. So what I do now is, after the closing HTML tag, I append a small JavaScript snippet which displays a little box which is either green or red. So each developer will immediately see if its HTML is valid or not. Yeah, of course I prepared a demo for this. Let's see if it works. Yeah, this is a small web app where I downloaded some web pages from that, and here's the description. And you see, here's the servlet filter. It checks all URLs, and it currently uses the publicly available validator. But of course, if you do this internally in your company, you should install your own validation service, so you have it on your intranet. Yeah, let's start the Tomcat. And here we go. So what you see now is the HTML page, and you see this yellow box there, and now it turns red. Wow, great. Well, not for eBay maybe. And I can click on the view result button, and then I get all the errors which are there. Okay, I don't want to get into detail here. And I also wanted to show you valid HTML page, of course. There are some on the internet. Okay, it works. Fine. Some final thoughts for this technique. Try it out. The Servlet filter is open source. Just download it, try it out, and feedback is appreciated, of course. Another point is how to deal with ads. Yeah? Sometimes, if you have an enterprise website, you need to integrate third-party HTML snippets, ads, or whatever. And of course, sometimes those third-party snippets aren't valid. What to do about it? You can't change them because you have to integrate them. So the first thing, maybe most easy thing to do is to integrate a switch into your web application to turn off ads. That's nice. If you develop and don't see the ads, I think it's cool. It makes your website faster. And if you can't do this, maybe it's important to have those snippets. Well, the most easy thing to do is to have some special HTML commands in your produced HTML, and then extend the servlet filter. And before you send the HTML to the validation service, just strip out those third-party HTML snippets which you are not interested in validating. So you only check your own HTML which is surrounding those snippets. Yeah, so much for the technique number one. Technique number two, a little bit similar, continuous CSS validation. Same idea, prevent layout bugs by always delivering valid CSS. And once again, I would like to ask, who does this at a regular basis in its development process? Oh, two guys. Cool. Okay, this is an Opera developer, I guess. Yeah, why? Once again, it's so easy to have a typo in your CSS. And when you have typo, the whole block of CSS rules will be ignored by the browser. I mean, CSS is quite robust, so if a block is not valid, it just takes the next one. But yeah, I guess a block which is ignored has some meaning. So you will probably have a layout bug somewhere if you somehow enter some characters because you wanted to commit it and it should be a commit command, but the commit box didn't pop up in time. I guess you all know this kind of errors. And so you definitely want to have valid CSS. So yeah, there are browser extensions, of course. But this is the same slide that you already saw. Same arguments apply. Can't make the build failed. So can we maybe scan files during the build process? CSS is not only in CSS files, it's also in HTML, in style elements, or even in style attributes. But nevertheless, why not validate the CSS files? Turns out that most of the CSS normally is in CSS files. And style elements or even style attributes are rare, not so much used. I guess it depends from website to website. But often there are a lot of CSS files, and yeah, why not check them? So, of course, we don't want to reinvent the wheel again. And yeah, there is a CSS validation service already provided by the W3C. And speaking of layout bugs, there's one layout bug here. Does anybody see it? It's hard to spot. Didn't occur to me for a long time. I give you a hint. First I thought, wow, is this by intent? Did you really want this design to be so? Well, I did some investigation. There is an image for the upper right corner. Well, if even W3C don't get it right, I guess there's really an issue about layout bugs. Well, should you use this validation service? It complains about something we know as CSS hacks, like this one. We don't want to have warnings, then we do such things by purpose, but only about some CSS. There are a lot of CSS hacks which are absolutely okay. The star CSS hack, which is often used for IE, is absolutely okay. So you can go with CSS hacks and don't get warnings. But then again, the CSS validation service complains about unknown CSS properties. Most of the time, browser-specific ones, like mod border radius, or the typical IE ones with inline JavaScript expressions, or those alpha helper. I don't know. What we did 2 years ago in a project was to use this CSS validation service. The nice thing about this, it's actually Java code which you can download, and it's open source, so you can modify it and twist it to your needs. The markup validation service is, as far as I know, a bunch of Perl scripts which you need to install on a Apache server. But this is just plain Java code, and I built a mojo around it. This is a snippet from our pom XML. And what we did was to validate all CSS files except those which are meant to be for the IE, which were included by this conditional command in the HTML, I guess you all know. So this doesn't validate all CSS, but a lot of CSS. Yeah, it worked quite well. And I thought about open sourcing this mojo too, but it turns out all the code which is really important fits on one slide, so I decided not to start another open source project. They can put it on one slide. Yeah, I don't want to go into details here. You can have a look at it later. If you want to play around with it, just download it and see if it fits somehow in your build process. Of course, you could also validate CSS during your front-end tests. I mean, doing scanning CSS files, you already know, is a good idea. You should do it on your CE machine, so the build will fail. But what about the CSS which is in HTML? And yeah, once again, use front-end tests. Why not? You can do this. It's the same like the HTML validation in front-end tests. And why not have a servlet filter? I haven't done that yet, but it sounds like a nice idea to me. Okay, there's one problem, I think. How do you get feedback? Because you can't attach JavaScript to CSS, so you have to have some state or parse HTML and then go back forward. Maybe one come up with a nice solution for this one day. But valid CSS is by far not good enough. This is a recording of browsing the public website from the German television station. And you see, even if they had valid HTML and valid CSS, there are some image resources missing. The browser requests all the images found in the CSS and gets 404 errors. Or another thing is, this is a special page in their website, and I guess they had some design refactoring and some CSS changed, and there was one special page. This old HTML doesn't fit to the new CSS, and so you get something totally broken. Even if you have valid HTML and CSS, the website doesn't look good. And this directly leads me to technique number 3, detecting layout bugs using JavaScript and image processing. What is the idea here? The idea is nothing less but detecting layout bugs by simulating the human eye. And, wow, that sounds a little bit like artificial intelligence. And well, nobody has a definition for intelligence, so maybe it is. But it's quite easy in that. Just some clever algorithms. So let me show you some more typical layout bugs. E.g. this one. The text goes on, so it's truncated here at a vertical edge and also here. Or another one, this is a widget which there's not enough space for showing all the status text, so it breaks in another row, but you don't see it. So the text is truncated as a horizontal edge. Or this one, here the text is not truncated here, but it overlaps the vertical edge. And this doesn't look professional. The bad thing is, if you have layout bugs, this just looks unprofessional, and you don't want people to think about your company to be unprofessional. And this even those layout bugs are everywhere, even on sites of big companies. Here, this is most of the time not the home page, but some page deep down in the navigation hierarchy. Here is my Yahoo profile. There's, I guess this is a localization issue, and German text is most of the time longer than English text. So the overlaps here, the input box. So how can we, another example. Means there's no overlapping, but I think there's some space missing. This doesn't look good, does it? So how to automatically detect those types of layout bugs? Here's the idea. The first thing is we need to know which pixels belong to text. And then we need to know which pixels belong to a vertical or horizontal edge. And if we know this, we can do some AND. And if text pixels and edge pixels overlap, we have found a layout bug. And then, of course, we need to somehow report this found bug. So let's start with detecting text. I have written a simple text detector, and it works like this. Then, as I expect, there's a front-end test, and I have WebDriver for the page. And the first thing I do is I inject my favorite JavaScript library into the page, jQuery, and then I do jQuery star. This selects all elements, and then I say CSS color black. And this means all the text of every headline, every link, every paragraph becomes black. So I take a screenshot, and then I say give all text on the page the color white. And then I take another screenshot, and all I have to do now is compare those two screenshots, and all different pixels are probably text. Now let's see how this works in practice. This is a page I want to analyze. The first thing I do is make all the text black, there. Then I do make all the text white, and here's the difference. Wow, really, this is all the text pixels. The purpose of illustration, put the original page in the background, fade it out. Yeah. Oh, it seems to work. First problem solved. Next one, detecting vertical edges. I think edge detection is actually a problem already solved in computer graphics. There are sophisticated algorithms for it, but I don't like sophisticated algosms. Most of the time they are quite complex. And we are only interested in vertical and horizontal edges. And I came up with I hope, a little bit more easy algorithm. Once again, I wrote a simple edge detector, which injects jQuery. And to help myself, I set all the text to transparent at the beginning. So I have no text, so I can concentrate on detecting edges. And of course, I take a screenshot. Then I find vertical pixel sequences of a certain minimal length where each pixel has the same color, or at least a very similar one. And then I select those which have a high contrast to the left or the right. And these are my vertical edges. I have to do some cleanup. I only want to have vertical edges of certain lengths. But works quite well, we will see. So here's my page. First step is to let all the text disappear. I'm not interested in text here. I'm interested in vertical edges. So, well, we have a lot of candidates here. These are all candidates for vertical edges. Same colored pixel sequences. But if I look for pixel sequences which have only high contrast to the left or the right, I get this. And last step is to clean up those little artifacts which haven't the correct minimal length. And I think the minimal length here was 16 pixels. And wow, seems like detected all vertical edges. And of course, you can do the same with horizontal edges. And if you put them together, you have all your vertical and horizontal edges. Cool. So we have our text pixels. We have our edge pixels. Let's do an and. Hey, cool. There it is. We found a layout bug. Let's report it. I have a little class called LayoutBug with a helper method markBuggyPixels. And what I do, if you look back, this is hard to see. And this is even the faded version of the website. So what I do is I replace each buggy pixel by a circle with radius 5 of black pixels, so I get a buggy area. And then I find the outline of this buggy area and draw a thick red line around it. And this turns out to work really nice. So here's my buggy area, drawn by small circles around the buggy pixels, and this is the outline. And I can't stress this enough. This is an automatically detected layout bug. The first time I saw this picture, I leaned back and said, wow, this really works. Of course, there are other types of layout bugs, e.g. this one, for example. Did you see that there's text there? I can't read it. Okay, I know what's standing there. But it's hard to read. And I think this is a layout bug. Text which is hard to read. There can be two reasons for it. Here, you can select different color schemes. But sometimes it's also the case that your CSS is broken. You have forgotten some CSS selectors, or you have changed your HTML, and suddenly you have black link text on blue background, or you have white link text on yellow background. And yeah, I see that quite often. So how do you go about those types of layout bugs? Well, we need to know which pixels belong to text. Oh, already solved this problem. The next thing we need to know is the background color around the text. But that's not hard to do. Just get the outline of the text pixel and look what color they have. And last thing we need to know is the actual text color. It shouldn't be that hard, should it? I mean, green and black, isn't it? But if you zoom, this is what the actually rendered by the browser. The text is anti-aliased, and if you look closely here to the L, this isn't even black. This is brown, magenta, blue. There's no black pixel in the L. Oh. But turns out you don't really have to know the exact color. All you need to know is, does it have a high contrast to the background. And if not, it's a layout bug. So I don't want to get into the details here, how the algorithm exactly works, but I want to announce an open source library I have put online. It's called Fighting Layout Bugs. Try it out. What does it offer? Not much at the moment, but it does offer an detect invalid image URLs detector. This one scans for image elements, which an invalid source attribute. Maybe the source attribute is empty, or it points to an image which produces a 404 response. Then we have this detect text near or overlapping horizontal edge and vertical edge detectors, which I just showed you. And we have this detect text with too low contrast detector. Yeah, long class names aren't there. Yeah, and of course, I want to show you how it works. So let's start with this detect text near or overlapping vertical edge test. Let's zoom a little bit. Here we go. I have a WebDriver instance. It's a Firefox driver, by the way. Currently, only the Firefox driver is capable of taking a screenshot, but the Chrome driver will be able soon, and the Opera driver will be able too, which is should be released, I hope, this year. If not this year, then of course next year. And yeah, what do I do here? Just instantiate the detector class, and then I say, I give the screenshot directory. I don't have to do this, but if I do, the detector will take a screenshot and not only say that there is a layout bug. And then I say, find layout bugs, and I give it the driver. And this will analyze the current page. And yeah, hopefully it returns a layout bug, which I print out here. So let's see if it works. It worked yesterday. You see the text detector and the edge detector at work, and wow, there it is. We have detected some text near or overlapping a vertical edge, and we have an URL of the page which was analyzed, and we have a screenshot. Let's take a look at it. Which one is it? Must be from today. This one. There it is. Detected text with near or overlapping vertical edge. Cool. Wow. Thank you. Thank you very much. Let's try another one. Detect text with too low contrast. It's actually the same code, just another detector and another website. Here it is, detect text with too low contrast. Find layout bugs, and let's see what happens. Yep, there it is. Detected text with too low contrast. Let's take a look at the screenshot. There it is. Text with too low contrast from today. Yeah, it worked. Once again. Okay. A small outlook. Of course, there are more typical layout bugs out there. The most often seen one, I think, is this one. You have different layouts in different browsers. This is Chrome, this is Firefox. And you see, here's a button that's behind the text input field. Here it is on the next row, it's broken. But here there's a link, which is not broken, or here it's on the next line. So normally you don't want this. Maybe it's okay for you, but normally you don't want this. And well, how do you go about this? When we have several WebDrivers which take screenshots, we can use them, and we need to somehow compare those screenshots. But we can't, of course, do it pixel for pixel, because there might be slight differences in anti-aliasing. So I guess we need to come up with some fuzzy algorithm to compare those screenshots. And I haven't tried it yet, because I can only take screenshots with Firefox at the moment. But I think the first thing is I blur the screenshot a little bit, and then I shrink it to a third of the size, and then I can do the comparison with some thresholds, so the pixels don't have to be the exact color, but at least the same color. And I think that should work. We will see when the next WebDriver release comes out. Here's another typical layout bug. This is a light box which displays a video, and unfortunately, the light box doesn't have enough space to contain the video, so you get scroll bars here. They don't make much sense, because if they wouldn't be there, the place would be a mess. So it's not nice. It looks unprofessional. What can you do about it? Yeah, scroll bars most of the time look the same. What you can do is it's a little bit like this golden screenshot technique, where you find sub-images in your screenshot. Yeah, let's detect scroll bars and images. And if your page isn't supposed to have a scroll bar, but we detect a scroll bar, then we probably have a layout bug there. Problem here is this is a detector which is not common. There might be pages which have scroll bars by intent, so I'm not sure how to deal with this. But it should be a sensible detector for pages which should not have scroll bars. Yeah, this is another one I often see. Some broken borders. You see, something went wrong here and here. There's some space between the border and the box content. This one is a little bit harder, but I still think this is automatically detectable, because just ask yourself how we detect this kind of layout bug. Where we see there's a certain pattern here, which marks the box, the top of the box, and this pattern continues here. And there's some space between it, some lines. I think this should be, you could express this in an algorithm. I haven't tried out yet, but I think it's doable. Okay, another one. Here's some text is truncated. It's not at the vertical edge, so I'm not sure how to go about it. I really would like to have an OCR, optical character recognition library in Java, so I could detect text in my page. And it should not detect this one because it's not complete, and so I could compare it. But I haven't found a good OCR library yet, at least not in the Java open source world. And the last example is, besides the bad spacing here and here, there's an indentation problem here. I think so. I really have no idea how to go about this type of layout bugs. I hope you have some ideas. Don't have an answer for every question. But it would be nice to detect those types of bugs too, wouldn't it? Okay, once again, back to the fighting layout bugs library. It's really not more than a proof of concept at the moment. But I hope is that it becomes something like find bugs. Yeah? Find bugs is a library which detects typical programming bugs in Java classes. And fighting layout bugs should become a library which finds typical layout bugs of web pages. Sounds something similar. Of course, contributions are welcome. If you have examples for layout bugs which are online, send them to the group. I would like to have a catalog of typical layout bugs, and if we have such a catalog, we can think how we go about it to automatically detect those. If you have ideas for algorithms to detect automatically layout bugs, let us know. And if you want to contribute code, feel free. It'd be nice if I could start something here. Some final thoughts. Of course, there are many open questions. I would like to try to answer two. First one is, when should detectors be executed? First option is, of course, you can once again write a separate front-end test, which visits some pages, which you know your website best. You know which pages are special and need some attention. I'm so enthusiastic. That might work, but maybe it's also valid to explicitly express in your front-end tests that you assert that the current page has no layout bugs. And in this matcher method, has no layout bugs, you trigger those detectors you want to use to detecting layout bugs. Or the third option, why not every time you get a new page or click on something or make something change, why not find layout bugs every time? Well, turns out, you have seen the test, it takes some time, some seconds. And the more detectors you use, the more time it will take. But on the other hand side, if you do this once in a night, in a nightly build, who cares if it takes 1 hour or 2 hours? And the last thing I want to mention is, what about false alarms? What if a detector says, oh, I detected a layout bug, and you look on it and say, no, this is my design, I want to look at it like this. Well, you can contribute a patch to the Fighting Layout Bugs library. But then again, let's look how findbugs deals with those false alarms. The first option is they have a configuration file to exclude certain classes or bug detectors so we don't get false alarms. I think it's quite easy to do a configuration file which has some URLs and some exclude patterns, so some detectors will not be executed for these URLs. Maybe another idea is to exclude certain areas of the screenshot. Not the full page, but only certain areas. Maybe with some kind of coordinates, or maybe with some pattern recognition where you specify the region, the top left corner of the region, bottom right corner, or maybe an alpha mask. I'm not sure. Let's start with an URL and ignore a detector for a certain page if we know this is a false alarm. Everything else is improvement. Or option number 2, findbugs has also this capability to scan the source files for commands, or this, sometimes I think they also support annotations in the class files where you explicitly specify this is some Java code which I know breaks findbugs, but this is by intent. And I could imagine to invent some kind of special HTML commands which the detector parses, and if it detects it, it just says, okay, I know you don't want me to report the layout bug here. Okay, so quite easy, isn't it? Yeah, and yeah, that's the last slide. And before I take questions, I would like to thank you for your attention.
That was a very interesting presentation. I must say, there's going to be more of a political battle where you're going to try and tell the developers there's a whole bunch of bugs and tell the testers that they didn't pick many of them up. One of the questions that I want to ask is, you mentioned about testing these layout bugs across browsers, but I was not sure if you actually pointed out in your, in one of these programs, how you actually do that.
I think this cross-browser problem is a special one, because all other layout bugs can be tested in one browser. How do you go about it? Well, I guess if you use WebDriver, you have one API for all kinds of browsers. So you can take a front-end test, run it against Firefox, and in the future, run it against Chrome, run it against IE. Oh, IE would be a problem. You don't take screenshots on IE. Run it against Opera, and the same front-end test run in different browsers, and all the time to check, oh no, that wouldn't be a solution. You have to compare it. Damn. Okay, no, you can do it, but you have to somehow know which screenshot from one browser belongs to the other browser. And if you have the screenshot of the same page from two different browsers, then you must feed this into the detector, which we haven't yet, but if we have it, you can compare it. I hope this satisfies somehow your answer. I have a solution in code yet, but I can imagine it is possible. The precondition would be to have a screenshot of the same page from one browser and the same page, a screenshot of the same page from another browser, and then a clever compare algorithm. I don't think it's that hard.
Hello. Thank you for this presentation. I think it's a bit of a sort of Christopher Columbus solution to this rather clever solution to something like this. Now my question is, I think you mentioned zooming. I find myself zooming a lot web pages and scaling the text up 3-4 times, so a lot of pages break down. You can detect that as well, I guess. And detect it automatically as well.
If I understood the question correctly, what about detecting layout bugs when you zoom in the page? I only zoomed on one slide to show you how text looks magnified. But of course, this is a big problem. If you zoom a page, the text gets broken, and sometimes this causes layout bugs. I haven't seen this very often. I'm not sure if WebDriver supports zooming. We should. Should we? It's supported. Yeah? Yeah, maybe we can do it with a keyword shortcut for zooming. Yeah, of course, it's an absolutely valid front-end test to zoom your web page and then trigger the layout bug detectors. Yeah, you should do this.
Would this work with something, say, like Canvas, if you've got words in a canvas and suddenly the words are overlapping? Because obviously, looking at it visually, it's a layout bug, but you can't actually hook into the canvas to see how things are viewable.
Well, this wouldn't work, would it? Only the current detectors which I have programmed only detect text overlapping edges. So the question here is, how do you detect overlapping texts? I could imagine that you can, if you somehow know your web page good enough, you can hide certain elements with JavaScript and take screenshots. And if you know, well, there's some special box, some special canvas, which has like, just hide the text in there, take a screenshot, that detect all the text which is on the remains on the page, and then flip around, hide all the other text, and just display the text in the canvas, detect the text pixels, and then once again do a bitwise AND. If they overlap, you have found an error bar.
Oh, thank you. A couple of simple questions. Do you use it in your production process?
Not yet.
Then no more question, I think. I just imagine how efficient, how much efficiency it has in a real production process. You know, we used to continuous integration process to be detecting every day, every single commit of our HTML guys, you know. And if we have several tens of several hundred commits every day, so can be highly detectable or it can be raising false alarms, so on.
Yeah, this is always the same with new technology. This library is quite new. I have developed it in the last months, so and if you introduce new technology, do it carefully, step by step. So what I propose is start with a nightly build, which just checks some pages and see how many false alarm you get and how long the detection of layout bug takes. And when once you start it, you can incrementally go from there step by step by checking more pages or do the tests more often. Let's see how it scales. Maybe we can also parallelize the detectors to run on different machines, so the time it takes to detect layout bugs shortens. Yeah, but start with a little step and see how it goes from there. Okay?
First of all, I'd like to say thank you very much, because you're going to make my design team very, very, very happy. So thanks in advance. The second one is advance warning of a request that I'll probably ask for you and anybody else working on this. One of the biggest layout issues that I find in our application, and it's a proprietary application, is we need to scan vouchers or some text or images and then serve them up later on for somebody to validate and say, this is good, this is not good. And I find that we waste, I don't know, 40% of the time telling the people who scan them to do a better scanning, because if they scan it and look it up as a regular image, it's fine. But if they serve it up on a browser, any browser, then half the time we have to send it back in. So I guess I'm fishing for ideas. Do you think we might be able to muck around with this so that we are testing images of images of images in order to try and, even if it just points out, 10% of the errors, then I'll have saved up a lot of time for that. So you may not have an answer right now, but I'll be following up with you quite a while. Cheers.
Okay, I'm a little bit overwhelmed by this question. Test images for images, test images. I mean, what I use here is a combination of image processing and some clever JavaScript. And you can't do this if you just have a screenshot. So you need to have the access to the analyzed page in a browser, so you can execute some JavaScript to easily detect layout bugs. Yeah, that's all I can say at the moment. But let's discuss. I'm very interested to learn about your process of detecting layout bugs. And what kind of layout bugs do you have? Let us know. Maybe we find a solution.
So there was a class of layout bugs that I didn't see mentioned in there, but
Yeah.
I did see demonstrated. On your Yahoo page, it has your picture and then the text box, and the text box is below the picture, when based on the styling of the text box, it should definitely have been to the right. And I think that was, again, because the German text for the submit button ended up being too long and pushing the flow down. So I guess that would be a flow error. And the only way I could think to detect that would be some kind of rule somewhere that says this is supposed to be to the right of this. And I'm just wondering if you think this library is going to evolve to cover those kind of layout bugs as well?
Yeah. Short answer, no. The long answer is, actually I wanted to present a fourth technique. And this is, the idea is interpreting the design as an actual requirement which you have to test. This means if you say it must flow to the right, this is a requirement you have to test. And I think what this library gives you is the starting point to build your own tests, to validate your design requirements. Another example would be if you have a design, normally you get a grid, which says the main column is 200 pixels, and the right column is 100 pixels, or something like that. And there's a space of 10 pixels between it. But we have a vertical edge detector. Why not apply it and see if the edges matches our grid defined by the design? And I think, maybe, I hope, you can use some code bits from this library to actually verify your design requirements. But I don't think it fits into the library because it's